The question is that we must expand sin 5 theta. What they are actually saying is that we must put sin 5 theta into an answer where there's nothing in front of the theta. So it must be something like sin theta plus 5 cos theta. But remember, this is just an example, okay? So there's nothing you'll see there in front of the theta in terms of any constants. So how to do this? We need to use a couple of manipulations to do this. First of all, we can use the Moivre's theorem. The Moivre's theorem, if you can remember, says this: if you have the modulus, let me just write this a bit neater. Let's say you have r, that's the modulus cos theta, the modulus of the complex number. So r is the modulus of the complex number, and then you have the bracket cos theta plus I sin theta, and then you have everything to the power of n. You can actually write this as r n bracket cos n theta plus I sin n theta. So you can see there we want to use that fact to solve this this question. Okay, so now we're going to use the strategy now. Obviously we know, okay, this is, remember, just to recap, this is the polar form of the complex number. If you had to write that in the rectangular form, which is the usual form of complex numbers, well, not usual I guess, but it's what you were introduced to in the beginning. When you are introduced to complex number, you write it in the rectangular form, and then you go from there and you write it in the polar form in terms of, you know, the angles, cos and sine, and then after that you will be introduced to the exponential form. You can write the complex numbers in. But anyway, we're going to use this fact then to solve our question, to expand sin 5 theta. But let's start and see how we will do it. Well, first of all, we're going to start then with the Moivre's fact, just to see if we can expand sin 5 theta. We know from the Moivre that if we have cos 5 theta plus I sin 5 theta, you see I'm going to use sin 5 theta in here for a purpose which we will see. So so it's not, we're not going to get sin 5 theta straight away, but we need to use some information to get eventually to the answer of sin 5 theta. Okay, well, we can write it then as cos theta plus I sin theta to the power of 5. Okay, so there we have sin 5 theta, and now we can see some sort of clue here. All the answers at the cos 5 theta will be equal to all the answers of in this side which doesn't have an I in it. Okay, so if we expand this cos theta plus I sin theta to the power of 5, if we expand it, so we multiply the 5 in a sense, then we can put the cos 5 theta equal to all the terms that doesn't have an I. But the sin 5 theta will be equal to all the terms that have an I in it. Okay. For example, I just want to give an example. So let's say you have 2x plus 3y. Then let's say you write here ax plus by. Okay. Well, we can see, because there's an equal sign, we know that everything in front of the x's must be equal to each other. Okay, so the a will be 2 and the b will be 3. And this is the same concept. You're looking for all the numbers without the I are equal to cos 5 theta, and all the terms equal to sine, all the terms with an I, because there's an I, I've scratched now so much, but all the terms that have an I in it will be equal to the sine 5 theta. Okay, so let's try to work this out a bit further. Okay, so let's expand that. Basically what we want to do then is we want to take cos theta plus I sine theta to the power of 5, and we want to expand it. Now how do we expand this term then? Well, we can use the binomial theorem to do this. And so how do we do it? Well, you say it's a sum. You start with r equal to 0 to 5 because it's to the power of 5. Then you use combination 5 r. Then what you do is, now you must be careful, you use this first term and you put it to the power of that 5 minus r, okay, and then that whole term there, so I sine theta. So you say I sine theta to the power of, well, that's just r. Okay, now we need to substitute r starting with 0 into this term here, and then start with 0, then 1, then 2, then 3, and adding all the terms. That is what the sum means. Okay, so then I just want to give some spaces, so I'm starting with the equal sign here. So let's just substitute 0 in, so you'll have 5 combination 0, then you'll have cos theta, okay, to the power of, well, it's 5 minus 0 is just to the power of 5, isn't it? Okay, and then you'll have, well, I sine theta to the power of 0 because we substitute 0 into the r. Then it's adding. Well, now the r becomes 1, so it's 5 1, and then it's cos theta, and it's to the power of 5 minus 1, so it's 5 minus 1. Then you have I sine theta, and that r now becomes 1. Okay, then it's adding. Now the r becomes 2, so you'll say, well, it's cos theta, and it's 5 minus 2 I sine theta to the power of, well, that was 1, that was now this 2, and then plus 5 3, and then you have cos theta 5 minus 3 I sine theta to the power of 3 plus, then you have 5 combination 4, and then you have cos theta 5 minus 4, and then it's I sine theta to the power of 4, and the last one, let's write that a bit neater, plus 5 combination 5, then you have cos theta 5 minus 5 times I sine theta to the power of 5. Now, if we just work this all out, 5 combination 0 is just 1, and cos theta to the power of 5 is the same as cos to the power of 5 theta. So you can also always put, you can put the exponent there, there between the cos and the theta. Actually looks a bit neater. Okay, then you have 5 combination 1 cos theta, so 5 combination 1 is just 5. Okay, then it's cos, well, this will be 4, won't it? So it will be cos 4 theta, and then there you have I sine theta. So we can put the I sine theta there. Then now you must be careful with this one. 5 combination 2, if you put it into the calculator, it will become 10. Okay, 10. Now this is cos theta to the power of 5 minus 2 will become cos to the power of 3 theta, and I sine theta squared. Well, now be careful now here, because that square will also go towards the I there, so it will be I squared sine squared theta, and then it's plus, okay, 5 combination 3 will also give you 10. You can check that. 5 combination 3 will also give you 10, so that is then just 10. That's cos squared theta, because it's 5 minus 3 is 2, and then that exponent 3 goes to the I and the sine, so it's I to the power of 3 sine 3 theta plus, and then your 5 combination 4 is equal to 5, so you have 5 cos theta, because that's just 5 minus 4, and that's 1, so it's cos theta, just like that. The sine, then it will be I to the power of 4 sine 4 theta, and then you have the last one, 5 combination 5 is just 1, and then the cos, that will be 0, the exponent will be 0, so it's cos theta to the power of 0, so that will just be 1, and then you're left with I to the power of 5 sine 5 theta. Now, what is important to realize now is that to work this out, what happens? Okay, cos 5 theta we can just keep like that. Cos 5 theta we can just keep like that. 5 cos 4 to the power of 4 I sin theta. We can maybe read it better by saying it's 5 I cos 4 theta sin theta. But now check this one. This is now actually important. This I to the power of 2. You remember I? What is I again? I'll just write it here. I is negative 1. If you square negative 1, square root negative 1, so I is square root negative 1. If you square that, you take away the square root, becomes negative 1. So this is actually negative 1. So 10 times negative 1 is negative 10 cos 3 theta sine squared theta. So now you see there's not an I there, okay? And now, oh, not equal sign yet, not so fast. Then 10 cos squared, this I to the power of 3. What does that mean again? Well, we know I squared will be negative 1. Okay, I'll just note it here. So I to the power of 3 is the same as I squared times I. We know that I squared is negative 1, and so you have negative I. So if we say, so it's 10 times negative I. So it's negative I, and then you have the 10 there, 10 cos squared theta sine 3 theta. Then you have plus, okay, again there. Now this is I squared times I squared, which gives you I4, okay? And what is that? Well, negative times a negative, 1, isn't it? So it's just a positive. So you keep it as 5 cos theta sine 4 theta, and then this last one, what will that become? Well, I to the power of 5 is I squared times I I. So you're still left with an I, but it's I to the square is negative 1. Negative 1 times negative 1 is positive times the I. So it's positive I sine squared theta. Okay. So now for our last step, and I'm running out of space here. Let's see if we can do it like this. I'll just write with another one, so I can always write it there. Okay, so then maybe let's try the green one. Okay, see if you can follow that. Okay, now just to recap, just go back a bit. This one, okay, we expanded. Maybe make it with a white. This one we expanded. But this white circled one is equal to this one there, which was cos 5 theta plus I sine 5 theta. So we know that all the things that has an I in it will be equal to sine 5 theta. So let's look at all the stuff which have an I. Okay, let's look at that. Which one will have an I? I just want to erase that a bit. Okay, Well, we can see it's this one there that has an I, that one has an I, and that one has an I. So it's 3 of them. So sine, you know what, just write that one out as well. Okay, so we know that sine 5 theta, you know, that's the one with the I now, is equal to, well, first of all is that one there, so it's 5 cos 4 theta sine theta. Okay, and the other I is that one there, but it's and remember the negative there as well, so it's negative 10 cos squared theta sine to the power of 3 theta, and that I there is just sine to the power of 5, sine plus sine to the power of 5 theta. So now you will see, and remember I didn't write I there, you know, because that's the thing in front of the I, because I also want just the answer for sine 5 theta. And again, just think about this example here I showed. So you say the 3 is equal to the b, okay? You leave out the y. So 3 is equal to the b, and this is actually what we did with in terms of getting sine 5 theta with an I there in front. Thank you.